to the students, to all the stakeholders involved directly or indirectly in the construction industry. And I feel that everybody who is participating in this India Construction Week would be benefited, and we will come out with some kind of a guidelines, with some kind of a recommendations at the end, which may be implemented, and if they are implemented, they would certainly help not only in the placement of the students but also for the development of the construction industry, because we feel that without infrastructure there is no development. And the present government has identified very good projects, very challenging projects, infrastructure projects which are to be completed in the coming years. Unless and until we have a knowledgeable society, manpower who is fully trained, we cannot have a Atmanirbhar Bharat. We have to work in that direction. We should not buy the technology from the foreign country. We should not buy the material from the foreign country. We should not buy the equipment from the foreign country. So in order to have Atmanirbhar Bharat, probably we'll have very good outcome from this India Construction Week, which would be useful. Those guidelines will not only be useful in our country, but certainly we will be mentor to other countries also. We'll transfer the technology to other countries. And this is what is the actual dream of India is. A digital India, new India. Jai Hind, Jai Bharat. So today I will share my views how to use laser scanner and unmanned aerial vehicles UAV for surveying work, which is a very useful technology in construction surveys. There are quantum jump in the surveying technology. If we see past 50 years, we had electronic total station equipment, then robotic total station, global positioning systems, laser scanner, and the latest one is the UAV and the drone system. So these are a big jump in surveying, which has made the surveying very, very easy. Now, why should we use the laser technology? This laser technology basically will give us very accurate three-dimensional coordinates even in adverse weather condition. So that is why this particular technology is very useful, because we get high degree of automation. It is safe operation. It is less affected by the atmospheric condition because of the fog, a hazy or rainy conditions. Sometimes we don't use surveying equipment. It's very efficient and very high post-processing efficiency we can achieve from this. Now there are advantages, there are disadvantages of using this technology. The greatest advantage will be we get three-dimensional data, which is the ultimate goal of any surveying equipment. So once we get three-dimensional data, we can create a 3D model, we can create a virtual model, we can carry out the measurements from those 3D model, and we can get the coordinates, accurate coordinates of the data. Disadvantage could be that it requires experience to use this, and hardware and software is little expensive, things like that. Now let us see on what principle this laser beam based equipment are working. We have a receiver in the instrument and we have the transmitter. As you can see, two boxes, the blue boxes which are showing the receiver and the transmitter, and then we have the target surface, and this target surface is the surface. It could be a building, it could be a tree, it could be a tower where the laser beam will strike, and this will return back, and reflected laser beam will come to the receiver, and receiver is decoded and convert into the digital signals. So at each point, because it is sending us a very large number of laser points, so at each point where it strikes on the object, we get three-dimensional coordinate, x, y, and z coordinates. And once we have a very large number of coordinates, very large number of points, we call it the point cloud data. So we are getting point cloud data with a very, very large number of. Now we can actually have a reflectance image. It is not exactly the image as we take from our mobile camera, but it is looks like an image like black and white photograph of a scan coverage, and it is highly reflecting. Points will appear light, highly absorbing points would appear dark, and so on. We have three types of LiDAR systems: terrestrial laser scanning systems, which are used in surveying. Then we have the mobile laser scanning and the airborne. As it is clear from the name itself here, we have a system which you can mount on the ground. You are very close to the object, that's called terrestrial laser scanning. When you are mounting this system on some mobile system like a vehicle, that is called a mobile laser scanner system. And when you are mounting this system on some aircraft or UAV drone, it is called airborne laser scanning system. So I'm discussing all the three here. This is a ground based system. So these are some of the terrestrial laser scanner which will measure the time of flight. That means the laser beam will be transmitted and returned back to the device, and the time of flight would be recorded by these terrestrial scanners. So different makes are available in different cost and in different specifications. These are some available face-based latest equipment which are available in the terrestrial system. We can use them for a very, very large number of application. As you can see, archaeology is one of the biggest application, then architecture and construction is another big application we are using for heritage preservation, and we are creating the virtual reality. In addition to these applications, we are also using these for slope stability monitoring, like landslide monitoring. We are using it in forestry sector, shipbuilding, forensic, biometric. So you can see here that it is not just the land surveying, but we are using it for multifarious applications. Now, how the instrument looks like, you can see the top right figure, which is the terrestrial laser scanner, and top left is the laptop device which is connected to that, and a power source, and there is a target on the bottom. So these are the devices which are required, and you can see in this diagram that on a building face several measurements are being taken with the help of the terrestrial laser scanner TLS system. And the dots which you see on the face of the buildings are those points where laser beam is exactly striking to the building and collecting three-dimensional X, Y, and Z data from these points. So very large number of points will be data will be collected, and these are called the cloud points. So you can actually recreate the entire building. Now we will also like to create a 3D model. So that means we have to use the photogrammetric principle, and we are capturing the image from different positions. So different positions will give you the overlap also, and the correct geometry you can recreate for the object. Now on the building phase, or maybe on a dam site or on a tower, we have to install these target types, and sometimes the coordinates of these points are also known to us, so they act as a reference point. So if I put these on the face of a certain building or certain structure and I know the coordinates, so I can use them as GCP's ground coordinates. This is the latest the view of the you can see of the terrestrial laser scanner. It can rotate 360° in the horizontal plane and 310° in the vertical plane. Meaning of this is that not like a conventional equipment, when you are bisecting the equipment in one direction, it will take just in that direction the data. But the modern device can take the data all around you automatically. So it has made the surveying work easy, data collection work very easy, and large amount of data you can collect very easily, quickly, very accurately with the help of these kind of equipment. There are certain technical steps which one has to follow in order to get the correct data. So we start from the survey plan, we carry out the field operation, then we go to the data preparation and the data registration with the help of the ground control points. Then once you have collected the data, you need some kind of a software, and that's your data processing software which comes over here. And then once you have done the data processing, then the last point will be that quality control and delivery. You want to create a digital terrain model of the area. You want to actually create a orthomosaic, that also you can do. These terrestrial laser scanners are available to us in static laser mode and the dynamic laser. So in static laser mode, you can see that pink boxes are three categories. We have long range, we have the medium range, and we have the close range. So there are three kind of equipment available in static laser scanning, where you are keeping it at a one particular point and taking the observations. In the dynamic laser mode, that you are mounting on some device which is moving. So always the laser scanner is always on the move. So in a static laser mode, there are certain applications which are given in the blue oval boxes, and you can see that it has application in civil engineering, it has application in city modeling, mining, monitoring the activities, and so on. The police is also using. Architects and planners are using. The archaeologists are using for preservation of the cultural heritage buildings in the 3D environment. This slide is showing you the process, how you are converting the data which you are collecting on the ground to a 3D model. So you can see at the bottom corner the laser scanner is there, and then it is taking the data from the earth surface, and the third point is the point cloud, so it is creating the point cloud data of that, and then lastly is the 3D model, where the data collected is used in the software to create the 3D model. Now, a point cloud data, very dense point cloud data, could be very confusing. You are not able to see anything out of it because it is so dense, and every single point has at three-dimensional coordinates attached to it. Now you have to do a certain editing, you have to do the cleaning of the data, and you have to be selective of the data what you want from this. So there are certain procedures one has to adopt, because the laser scanner will scan everything visible to it and will have the coordinates of those points. So we can see from this particular slides, we can use this particular data for dam sites, like deformation in the dam. bridges, deformation in the bridges, tower, inclination of the tower or verticality of the tower. So all that kind of study, the cracks which are developing in the structures can be very easily monitored with the help of the terrestrial laser scanner device. So you can see that model of the building. Bottom is a photograph of the building and top view is the 3D laser scanning, which has been done with the help of this terrestrial laser scanner. Now, once you have this kind of a data of the building, now you can calculate all the dimension of the building. You can carry out the measurements of the building. You can calculate the volume of the building. You know, people have also done the study that how much money I'll have to spend if I if I uh, have the color wash of the building, color washing or the painting of the building, how much money has to be spent. So, you know, that kind of a computation can be carried out with the help of this uh, bridge. You can see that the scanning of the complete bridge is being done by this terrestrial laser scanner, and any defect which is being developed in any of the part of the structure can be monitored in nuts and bolts. If there is any defect which is being developed can be monitored with the help of such devices. The deflection in the bridge, when the train is passing, there is a deflection in the bridge. When the heavy load is passing, there's a deflection in the bridge. So whether the deflection is within the permissible limit or whether the bridge is old, it needs replacement and so on. In civil and infrastructure, road and rail survey, for volume calculations of the material, for tunneling, for topographical survey, monitoring of the performance of the structure. So for all that purpose, we can use different kind of the uh, different scanners, laser scanners. So this is the example with the Leica scan station. So you can see the building 3D model has been created out of that building, and this is a very dense point cloud data, and what you see is that now the 3D coordinates of all the points. So this is a bridge. You can see even the railings very clearly, the deck, the pillars of that, and all the measurements can be done with the help of the 3D modeling. So this is again the terrestrial laser scanner is being used for the monitoring of the construction of the dam or the bridge side. From 3D point cloud data, you know, one can create these kind of 3D model. So second, what you see is Cyclone. Second picture, Cyclone ICP. Cyclone is the name of the software, and BA is the name of the software. So the software have been used to create, recreate complete building of the church. Here, structural deformation measurements have been carried out. When the load is passing through a particular structure, then definitely there is a deformation. Sometimes this deformation is within the limit, sometimes the deformation leads to the disaster. You know, the structure fails. So that deformation kind of a study, you can see the sag in the curve also, which has been monitored with the help of the terrestrial laser scanner. The second category of this is the mobile mode of the laser scanner, where we have a specially designed vehicle for that, and we are mounting our system. So this is the complete system which has been mounted, and this system now is equipped with the camera, with the GPS, with IMS and so on. So these are the details of this. So you can see that here we have GPS devices on the top, we have the IMU, and we have a 360-degree camera here. So this camera will take picture in all the directions. It will take the images in all the direction, as well as the vehicle will move. And then we have the laser scanner also, so it will collect the point cloud data. So we'll collect both kind of data, the image data and the point cloud data, and both will be very useful for different applications. So I'm showing you one of the image, the point cloud data which has been collected with the help of the uh, moving laser scanner. So you can see even the persons who are there on the street. You can see the railway track very clearly, and also what is written on the face of the building. And very clearly you can see the window panels and pillars. So all that details, if you zoom it up, you can see much more clearly, and each and every dimensions can be identified with the help of the data which has been collected with the help of the moving mobile 3D mobile scanners. So this is top one is indicating the railway track. So these are the tracks here, and by this side of the track you can see the vegetation, the trees, and also there is another track here. So one can even use this for the maintenance of the track once the data is collected with the help of such devices. So in foreign country, maintenance of the tracks, it is being used. Now you can see the bottom picture is the road, the entire mapping of the road, and the surrounding areas have been done. This is the hilly region, so that is why you will see so many curves on the road. And as you are moving in vehicle in the normal circumstances, similarly you have to move the vehicle on the road, and the instrument is automatic. It will collect the data on both sides of the roads, as well as the backward and the forward data, and which is very useful in a very large number of studies. So this is a system which is automated road survey system available with the Central Road Research Institute, and this is a very useful device where it has a laser scanning system. It has a GPS devices fitted to it. It has a digital camera. It takes the images of, and then the data acquisition system. So sometimes, you know, we have to carry out the analysis when we bring the data from the field in our office. But the advantage of this system is that you can do the analysis of the data in the field itself, you know, real time. So there is a real time data acquisition, and there is a system which is fitted in the vehicle itself, and you can analyze and see whether your data is correct or not, and what is the behavior of that. So this is a very useful equipment for maintenance of the road, for assessing the condition of the road and stresses in the road. You know, there are potholes in the road soon after the rainfall. So how much material would be required to repair those potholes? If there are cracks being developed, if the road is bumpy, then it can give you all that profile of the road. So we have, you can see in the front we have the laser profile meter. So here the laser beam will scan the entire road system, and then we have the camera system which will take the images of the system, and then GPS will give you the real-time coordinates. So this particular system has been used for PhD work, which has been already awarded. You can see that these are the two laser scanners, and these are the camera systems which are mounted on the entire vehicle. So two camera systems on the top will take the images, and these two images from the left camera and from the right camera can be used to create a 3D model using the photogrammetric principle. So this is like a moving lab. This is not a vehicle, but it is a moving lab, and it is collecting the entire data for the road survey which is required for its maintenance and for its repair. Now you can also mount this laser scanning system on aerial platform. So it could be a low-lying aircraft, or it could be a drone system. So here it is the aircraft, and the scanner now is looking downward, and as it is looking downward and the aircraft is moving forward, it scans the entire Earth's surface. So what is the meaning of that? That means that all the dots, laser beam dots, which are falling on the surface of the Earth, they are collecting three-dimensional data, and there is a GPS devices, and with the help of the GPS devices, you can actually geo-reference the data and can get the actual coordinates of the data. So this is, for example, the data set which has been collected by such a system over the Korea, and one can see that the different colors here are indicating basically the intensity of the laser beam which is reflecting back from those objects. So this is a gray scale. This is not the image, but this is a point cloud data which has been collected with a very high accuracy. So this is a technique which will give us very high accurate results even from the space. So this is again a LiDAR data, and what we see is million of points are there. So from these million of points, one can have a feeling of the river. So this is a river here, and then there are some impressions of the road and artifacts are there. So one can see that this is the LiDAR data, and if you want to study the forest cover, for example, from this data, the green is the all the tree covers, and then there is a bare area, the sandy areas this side. So I blow it up to this area, and you start now seeing those trees. I further blow it up. Now you can see the height of the trees as well as the surrounding area, which is the bare soil or sandy area. So one can carry out the, in fact, the measurement of the biomass from this kind of you can also find out which are the further suitable sites for plantation of the trees. So one can do the detailed study. 3D flood modeling. Our country is facing a lot of problems due to the flood, and flood is never studied now in 2 dimension. This is because it is a function of the slope also. So we are studying the flood in 3rd dimension, and the laser scanners which are mounted on the aircraft can give us very useful data to study the flood in the 3rd dimension. Now this is a study where people have carried out a mapping of the area, and you can see the different buildings and rooftop of the buildings and with different colors. So what the different colors are indicating, these colors are indicating the potential for solar energy, because there is a lot of potential in our country to tap the solar energy and use it for some purpose. So we can use it like we use the normal energy. So here the sunroof which are oriented in the proper direction, like red one is showing you the high potential. So we can get that which is the rooftop giving us the maximum area where we can have the solar plant, solar panels fitted on the rooftop. So is giving us the area as well as the orientation of the rooftop with the help of this. So there are very large number of applications of the LiDAR survey, and you can see here there might be some applications related to the civil engineering, but there are other applications which are related to the outside civil engineering. But the basic thing which is common here is the mapping aspect or the data collection aspect and its integration with the other data, maybe remote sensing data and so on. The other very useful technology which is coming up is the drone technology. This is called, technical term is the unmanned aerial vehicle, UAV, but you must have seen the drone actually in the marriage party or the function, taking the images of the area. So if we see, the pictures from the space were taken way back in 1849 from the balloon, from a low height platform. Balloon was the platform. Then the Kettering bug, which was used in World War One. So this Kettering bug flew to a certain height and took the images, and then this has led to the development of the drone technology. So Queen Bee was one of the first and returnable usable UAV which was in practice. If we see from where the drone term has come from the Queen Bee. And if you see the shape of the bee, drone is similar to this kind of a shape. So the drone has derived its term from the term bee. Now, if you see the technical term, they are called unmanned aerial vehicle UAV. They are called unmanned aerial system UAS. They are also called remotely piloted aircraft systems RPAS. So these systems have developed over past few years, and this diagram indicates the development which has taken place right from the 2006, and this is continuing, and we are getting better and better technology. We are getting better and better sensors and better software in order to analyze the data and useful for different applications. So you can see here that earlier it was combustion engine platforms, and now we have the electric platform engines. Now in drone 2000 onwards, it has completely changed, and we are having this kind of systems which are very small in size and have a lot of flexibility. So UAV is a remote controlled pilotless aircraft which is flying without people inside controlling it. So you are controlling it with the help of some controller, while autonomous remotes you are even not controlling with that, but there is a ground stations which is monitoring its movement. So you have you don't have the pilot inside, and you are controlling it with the help of some gadgets or device on the ground. So you can see we have two types of basic two types of drone. One is the fixed wing. So this wing is fixed here, and another is the rotatory wing. So we have, for example, these vanes are rotating here, 1, 2, 3, and 4, right? So we have a fixed wing types and the rotatory wing type. These are the two broad categories. The fixed wing types would require a certain kind of a runway actually. So because they require certain horizontal movement to get the thrust, and then they fly up in the air. But rotatory wing can go vertically up directly from a small ground or from the rooftop, so they don't require runway. So this is the advantage, but there are many other features also, like fixed wing is always moving. It cannot be a stationary at a point because it requires thrust, okay, while it is moving. But in the rotatory wing, it can be stationary at a point because the thrust is generated by the wings itself. So that means this can be used for surveillance, monitoring one area continuously for a long time. So we have under rotatory wing types, we have quadcopter or multicopter. Quad means 4. So you can see here that there are 4 different wings and vanes here. Then we have the hexacopter. So this is a hexacopter with 6, and the octacopter with the 8. So these are also known as the multicopter. Very, very useful, and most of the time you will find that quadcopter is the most commonly used UAV for surveying and mapping applications. They are also classified according to the weight. So some drones are very lightweight, we call it the small drones, and some are a little heavier, and the most heavier drones are used for military purpose and not for this civilian use. So here we are mostly talking of the drones which are used for the civilian purpose, for the commercial use. If you look at the anatomy of the quadcopter, it has various components. Uh, it has a camera system, as you can see here, that on the gimbal system, on the camera gimbal system, gimbal is basically the frame of the camera. It supports the camera system. It could be a multispectral camera giving you images in several spectral wavelength bands, or it could be a thermal infrared camera, things like that. So it has a camera system and it has the sensor also. So several sensors also can be attached. Suppose I want to sense the temperature, I want to sense the environmental condition of the area. So there could be several sensors which are installed. Then there is a flight controller and there are motor systems and so on and so on. So these are the different components of the then aerospace classification, because there are certain restrictions. So one cannot fly it anywhere or to any height or to any distance. In fact, one has to take the permission, and these regulations are varying from country to country. So one has to read those regulations, understand those regulations before flying to a particular area and to a particular location. And there are certain areas which are restricted, like the defense area is restricted, the airport is restricted, you know, the certain forested areas, so where it is uh, uh, not allowed to fly the UAV and take the images. Then there are certain terms which are used, like the autonomous terms. Like we have the autonomous cars now coming into the market. So they are based on the same principle. So we have the autonomous drones where the um, drone will fly to well-defined points up in the space. So GPS is helping us. So we have predetermined the coordinates of those points and the UAV will fly to those points. Then there are automatic also. You know, they can take a detour of the planned in case the environmental condition is changing. Then altitude hold means that it can stay at a certain height for a distance. So there are certain terminologies which we are using in when we are flying the drone. Now, this is a study which says that if we do land surveying or if we do the survey with our drone system, how much is the difference? What is the cost comparison? So this is the cost comparison. On y-axis you can see the cost in US dollar and the size in the acres. So as the area is increasing, you can see green line, which is the land-based survey, the cost is increasing. So it's a linear function of that. But in case of a drone, it is not a linear function. You can see that cost almost remains same if there is not much variation in the area. But if you go from 1 hectare area, 1 acre area to, let us say, the 41 acre, even then there is not a significant increase in the cost. So we can save a lot of money also from this. What are the other advantages of the drone survey? High speed of data capture. We can work with 1 or 2 person with this. We can collect a very large number of data with high efficiency, and the best part of it is the high spatial resolution data, 1 centimeter per pixel, and no technology can give us that high resolution data in such a short period of time. 3D modeling not affected by cloud coverage, because the laser beams can strike, can penetrate into the cloud, as we know. High temporal resolution, that means I can take as many images of a point as required, and it is a low cost technology. Now there are a very large number of commercial use of the drone, as you can see from the slides. that people are using for different industry, people are using for different industrial use. But if we look at the construction sector, so in construction site management, this is being used very frequently in foreign countries. Now, these are the benefits. We are getting very high precision, we are getting the improved productivity at the reduced labor cost, and we can scalable the data, and adaptability is more, and increased safety. So these are the additional benefits which we are getting. Now, if we look at the drone market, potential of the drone. So this slide is indicating that we have a very good market, and this is indicated in 2022, or here it is 2024. So we can see that globally, the world over, the it is on the increasing side. So market of the drone is very good, but it shows that the more of the application is on the defense side. So blue color is indicating more in the defense side, and the green one is indicating in the civilian use of the drone. Then how much investment is being done? This is shown the government investment, the consumer, the enterprise investment, which is being done in the hardware of the drone. So this slide indicating it is 2021, the US dollar which will be spent in the hardware. Okay. Some of the photographs now which you see here, which are taken with the help of the drone technology, and once the images are taken, these are taken with the help of some overlap region. Okay, so that you can create a 3D model. So sometimes the 80% or 70% overlap is there to create a 3D model. You can also create the orthophotos. So once you create the orthophotos, you can carry out the accurate measurements, and it acts like a topographical map. This is the orthophoto of an area which has been created by joining several images, and now this is just like a map, a topographical map, and any measurement now you can carry on this is as accurate as a topographical map. This slide shows that it has a lot of application, and we have seen the application of delivery of the goods and delivery of the medicines, particularly during the COVID time. So the drone, now everybody knows what are the application of the drones, particularly in the delivery of goods, delivery of medicines, and touchless kind of a delivery system. Then we are using in the construction. No, as civil engineer, we are very much enthusiastic to use it for construction of the facilities, whether it is a road, or it is a big stadium, or it is a big building structure, or a dam site or so. Then inspection of the infrastructure. So, it is physical inspection may not be possible to go to that particular site during the construction or maybe the post construction. And this inspection is done with the help of the drone. And Arunachal Pradesh, this is being done. The drone is sent to the rough site, tough terrain where it is not possible to go every day by engineers, and they are inspecting their sites with the help of the construction is being monitored with the help of the drone. Then safety and security. Then agriculture, forestry, and fisheries areas. So there are very, very large number of applications. This is a topographical mapping. So, as civil engineer, when we survey some area and we plan some infrastructure in the area, so first thing what is required is a topographical map. So you can do the topographical mapping, and with the help of these XYZ data, you can create a 3D model of the area. You can create the contours. So you can see the brown lines here are the contours of the different heights. So those circles, the green circles which you see are the tree crown. Volume estimation. We require in our projects, in our construction projects, in our infrastructure development project, we have to many times calculate the volume of the earthwork. So it can be used to calculate the volume of the earthwork. This example shows that how the drone is useful for the construction industry. So there are 6 useful applications are given. Number 1 is for the land survey. Number 2 is for building inspection. Number 3 is providing the visual material for the clients and the staff. Number 4 is monitoring the on-site activities. Number 5 is the security, surveillance, and mapping data. So different drones. So for example, you can see that different heights, the drones are continuously helping the construction engineer, planners, and managers. So this is all the applications of the drone in the construction industry. So it is collecting very useful data and providing the useful data to the contractor or to the engineer. We can also identify, once we collect those images, very high resolution images, we can identify unauthorized construction. You know, this is another big problem in many countries, including India, that we have unauthorized construction where the permission has not been taken from the municipality, and people are also saving a lot of taxes. You know, they don't pay taxes, but they construct the additional area without the approval of the local body. So unauthorized construction can be easily found once we have the repeated images. This is a caricature, a cartoon, which has been shown that how our construction site of the future would be. You know, in future, right from delivery to the building product, to workers, collaborative working, the site sensors, to the community, to the equipment, the drones, you can see these drones are there. So drones are going to play very important role collecting the data, providing the data, and helping us in efficient construction. In road transport, you know, what we call as the intelligent transportation system, also that they are helping us in speed control of the vehicle. In foreign country, the speeding of the vehicle is checked with the help of the drone. Then identification of the plate number for vehicle tracking, traffic counting, traffic monitoring. This is all done with the help of this particular technology. Now this is the 3D model of the ground of certain buildings. So you can see here that the 3D model has been created, and now this particular 3D model can be used for the planning. So this is another building 3D model which has been created with the help of the UAV technology. In a smart city, it is being used in a large way. So design of a smart city would require actually wireless sensor network, autonomous systems, which uses the UAV and micro UAVs. So in foreign countries, the UAVs are basically collecting real-time data and providing real-time data, and that is the main idea of the or smart cities. Then in industrial application like leakage in the pipeline. Okay, so this is all maintenance of the pipeline or leakage in the pipeline that is being monitored with the help of such drones. Very interesting application of the drone, which is gaining popularity, is in the filmmaking. You know, so far we were using the video cameras, the handheld cameras for capturing the films, the shots of the films. But nowadays, the drones are being used because the permission has been given to use the drones for filmmaking. So this is another interesting application. And the entertainment is another. Entertainment industry is coming in a big way where the drones will be used. And this is the one of the example where Lady Gaga Super Bowl show, where the several drones were flown up in the sky, and during the night time they were used for the illumination purpose to make a particular shape. So these are, for example, the 100 drones light show. So for entertainment purpose, for light and music show and other things, the drones are being used in a very big way. Now, there are limitations on the height. There is a limitation of the time also. So this slide indicates that how long I can fly the drones. You will see that some of the drones will give you up to 20 minutes of the flying time because of the power, because of the battery it consumes, and some of the drones can fly up to 1 hour or so, 50 minutes or so, depends. But there are drones for military applications which can fly much longer duration. So normal flying time will be 15 to 20 minutes with the average drones. So this is, I have already discussed with you this one. Um, there are revenues the which are obtained by the industry, which the industries are getting, the drones which are sold in several thousand. This slide is indicating the potential, the future potential of the drone, and uh, up to 2025, it is expected that very large number of drones will be used for various applications. Now, this is indicating that what is the market potential in which areas. So one can see that oil and gas industry, oil and gas sector, $633 million. In utility sector, $484 million, and so on. Mining activity, public safety, public infrastructure is 70 millions. So this is what the total market size is expected uh, in 2022 from the norm. Now, this technology is not used in isolation. This technology can be integrated with other available latest technologies. So this is indicating that what are those essential technology of the future. So you can see drone on the top here, that you are collecting the data for the drone, and but this uh, data you are using maybe for 3D printing, or you are integrating with the Internet of Things, or maybe the blockchain analysis, or maybe the artificial intelligence software is used to predict uh, the forecast, or to assess the trend of the data, or maybe the virtual reality environment, or augmented reality, or maybe stored on the cloud, and maybe the cloud-based applications could be developed, or maybe a robotic process automations. So these are the technology. uh, if they are used in integration with the drawn data, maybe a very large number of applications could be involved. So this is my last slide, which says that you can use these laser based technology and the drone technology for very large number of applications, for surveying, for large scale project, for small scale projects, and particularly for those areas where the access is difficult. So these laser based technology and the drone based technology, I would say, are the future uh, of the country, where a lot of data could be collected with the least manpower, very efficiently, and very uh, uh, effectively, for planning purpose, for monitoring purpose, etc. So that is all I wanted to tell the advantage of this particular technology. So thank you very much. I think I have covered, given you the insight of the use of the technology.
Namaste and welcome to this presentation in India Construction Week 2020 to be held during 1 to 5 December 2020. I am Professor T.I. Eldo, Institute Chair Professor and Head, Department of Civil Engineering, IIT Bombay. So I am going to give a talk on flood hazard management for smart city development by using computer simulation, remote sensing, and GIS. So as all of you know that flooding is a major problem, especially in India for last few years. So as far as urban development or city development is concerned, whenever flood takes place, it is a big issue as far as cities are concerned, and especially coastal cities. So when we look into these, the problems of urbanization, we can see that, so here, whenever the urbanization means, so lot of, say, pavement development, construction, and lot of areas are converted to impervious areas. So that way, you can see that there is a possibility of increased surface runoff in stream flow. So that is what is the output of the urbanization. So that means soil impermeabilization and decrease of concentration time, and then especially in urban areas we can see that increase of runoff, and then in most of cities what can happen is reduction of riverbeds, and then finally the outcome will be increase of flooding frequency. And then there is a lot of issues related to urbanization as far as the cities are concerned. So when we talk about smart cities, we need to look in such a way that we have to develop the city such that the flooding problems can be reduced. So when we look into the urbanization and its impacts on hydrology, so generally, so as I mentioned, the lot of areas will be converted to impervious areas, and that way in the cities there is possibility of increased in magnitude of peak runoff, and then decreased lag time between rainfall and runoff, increased rate of hydrograph and recession, and decreased mean residence time, and then topographical changes. Then there is no space for detention basin, like that, so many problems. So we are going to discuss what are the impacts of urbanization, or say in terms of a smart city, what are the problems with respect to the hydrology and, say, for example, flooding. So as I mentioned, flooding is concerned, say for example, if this is a, so here in hydrology we call it as hydrograph, so this is time versus flow versus time. So here if this is a, say, not an urbanized area, normal, like a village or a normal area without much urbanization, then you can see that the hydrograph, so it will be in a natural watershed, it will be something like this. But as I mentioned earlier, due to the heavy urbanization, a lot of areas are converted to impervious areas with respect to roads, buildings, and other areas. Then what can happen is that, so this hydrograph, you see that increased peak, so increased peak flow duration, and then compared to this higher peak flow, and then there can be more frequent stormwater runoff events and then related problems. So that way this all lead to flooding, especially in urbanized areas. So when we talk about smart cities, we need to design the city, we need to plan the city in such a way that this effect on hydrology like flooding is reduced, or flooding is managed in an appropriate way. So when we look into what are the problems as far as urban flooding is concerned, so as I mentioned, flood is the most threatening natural disaster. So if you look into condition overall in the world, and especially in India, we can see that in the last few years, a number of events, flooding events, we can see start from, say, for example, the last 20 years, starting from Hyderabad in 2020, then Ahmedabad in 2001, then Delhi in 2002, 2003, Chennai 2004, Bangalore 2005, 2006, Mumbai, a heavy flood in 2005. And now recent times, for example, in Chennai 2015 and Kerala 2018 and even 2019. So this, say for example, Mumbai is concerned, recurring floods in Mumbai region we can see in most of the years, and especially at least once in 2 years or once in 3 years, heavy flooding we can observe in Mumbai. And this is peculiar for coastal cities, just like you see that like in Mumbai or in Chennai or in Calcutta, all these places you can see that urban flooding is a major problem. And coastal urban cities, you can see that they are vulnerable to flooding under combined heavy rainfall. Being coastal means there is possibility of tides, high tides. So we need to look into how we can mitigate these flooding problems and what are the possible solutions. And when we design a smart city, what aspects we can look into, or how we can manage the flood if there is a possibility of flooding. So that is what we are going to discuss in this lecture. So in terms of flooding, so flood impacts and solutions. So as I mentioned, the flood is a major disaster. So it has huge impacts in terms of economy, then environmental impacts, health impacts. So there can be, some people can die. There is so many issues can take place with respect to flooding. So for example, Mumbai flood, what has happened in 2005. So death in Mumbai reported as around 500 or 454. And in Navi Mumbai it is 66. And about rupees 70 crores lost to MIDC in TTC belt. So like that, so much of issues took place in 2005, July 26 flooding in Mumbai. And say, for example, if you look into Chennai floods in December 2015, so more than 400 people died. And then there is an estimated loss of more than $7 billion. And more than 2 weeks, there was disruption in the city. And then the recent times in Kerala, so 2018, if you look into Kerala flood, was very, very severe flooding took place in August 2018. And more than 300 people died, and economic loss was, say, estimated is more than 30,000 crores. And disruption of many places, including Cochin Airport, for more than 2 weeks. So when we look into this flooding, what are the major factors responsible? So you can look into a mixed bag of causes. So like a heavy rainfall, one reason, then inadequate drainage, then there is it's maintenance, the maintenance issues of drainage system, and then as I mentioned in coastal cities, tides, floodplain, occupation, etc. Like there are so many reasons. So in this India Construction Week, I'm going to discuss how we can manage the floods. So what are the way we can do in terms of computer simulations, and then what kind of mitigation management practices which we can do as far as flooding is concerned. So this is an important problem, especially when you talk about the construction week. Though, as I mentioned, I am talking in terms of when you develop a smart city, we need to look into all these aspects. So for flood management, we need to look into the various design practices, then maintenance of the drainage system, then awareness. So in terms of engineering, we can try to model or we can simulate what is, say, for example, given rainfall conditions, or say return periods, 100-year return period, 50-year return periods. Various scenarios can be generated, and then we can assess the various options, and then we can develop a smart city in terms of its implementation. So as I mentioned, in India, this flooding is a major problem, and you can see that due to climate change impacts, which is reported last 2 decades, and then its impacts or due to the drastic changes as far as the land use, land cover is concerned. So you can see that especially coastal areas, the flooding is increasing, as I mentioned already. So there is a series of events last 20 years. We can list some of the events like Kerala floods in 2018, Chennai floods 2015, Uttarakhand floods in 2014, like that. And then also, especially in the eastern belt, from the Bay of Bengal, you can see that cyclone is a major problem, and then the flooding problems due to cyclones. So these are also, you can see, especially in this area. So when we look into the flood management, we need to, as I mentioned, it can be heavy rainfall or various other reasons. So we have to look into, so last few years we are talking about climate change. So what are the, whether it is due to climate change or whether due to human interventions, all those things we need to look into in a holistic way. So climate change, as I mentioned, climate changes will have a significant effect on regional or local hydrology. So this is very much visible in India the last few decades. So alteration hydrology caused by climate are so complex. So you can see that it is what can happen in future. It is unpredictable. So now we can create various scenarios nowadays using global circulation models or general circulation models. So it is only in terms of we can create various scenarios or various projections. So these warming climates have potential to intensify the hydraulic cycle. Hydrology is concerned, then intensify the hydraulic extremes, and then changes in rainfall seasonality. So we can see that there can be human interventions. So as far as human interventions are concerned, mainly the change in land use, land covers. You can see that urbanization is increasing. So if it was hardly less than 20%, say 20 years back, now it is going to more than 40% urbanized areas in India. So that way, we need to see that the human interventions, the changes in land use, land cover, and then changes in crop shifts, mining, deforestation, all these affects as far as flooding is concerned. And dams and diversions change river courses and river flow patterns, and rapid growth in urbanization increase in various areas. So that way there is a need to distinguish the impacts of climate change from human interventions. And then we need to study in detail when we talk in terms of smart city development. So here you can see in this slide the flood impacts and management. So if you consider a city like this is, for example, in Cochin city area in the 2018 flooding, you can see that many areas are flooded and even the water has come to the roof level. So that is why we need to look into, especially when we talk about the Indian construction, we need to design, we need to plan the cities in such a way that the flooding impacts are minimal, or we need to see that what kind of, if there is a possibility of flooding, what kind of mitigation measures can be taken care. So when we talk about urban flood management, there are various issues. So we need to study the hydrology in detail. So hydrometeorology we need to study in detail. Then how we can manage or how we can forecast the rainfall and then flooding forecast, so that immediate water management after forecast that we need to see. And then we need to see the urban flood modeling, the flood simulation. So that is what we will be briefly discussing here. And then we need to look into in terms of impacts, like what will be the flooding impacts, then what kind of adaptation and what kind of assessments can be done. So these are some of the major issues as far as urban flood management when we talk in terms of the flood management issues, especially in terms of a smart city development is concerned. So that way, when we talk about urban flood management, flood simulation or flood modeling is very essential. So role of modeling is very, very important. So nowadays, you see that especially when we talk about urban flooding, it is process is so complex, the hydrology is so complex, the land use, land cover changes are so complex. So we need modern tools like the remote sensing tools. A lot of data is required, and then geography information system is required, and then a numerical model or computer modeling is required. And then through this, we can develop flood hazard maps, and then by using the vulnerability, which areas are more vulnerable, and then this can, using this, we can develop flood risk map. So that will be very useful, especially in the smart city development or urban flood management is concerned. So when you talk about flood modeling, there are so many challenges. So the key challenges include data. As I mentioned, data is so much data is required in these kinds of modeling. So like especially the rainfall prediction, what will happen in the few weeks. So and then so what kind of drainage system is there, and then most of the time we need a high resolution detail elevation model so that we can see which are the areas possible flooding and how much flooding is possible. And then also we need to look into interaction between different processes, that also we need to see, like tides, release from reservoirs, impact of urbanization, etc. And then, so as I mentioned, when we talk about the flood management, now as I mentioned, there is so many tools are available, there is, say, efficient models are available. So we can integrate these tools like geography information system, then flood model, numerical model, and then also we can use the remote sensing data for all these aspects. So this figure shows integrated flood modeling, how we can develop a flood model, starting from, say, if you have got a distributed hydraulic model like this, and then we get the land use, land cover map using remote sensing data, and then everything is put it in a GIS platform, geography information system platform, and then using that we can run the flood model, and then we can say that, okay, what is the possibility of whether a particular area can be flooded. And so we can create scenarios in advance, say like 100-year return period, 50-year return period, 25 years return period. And using this, we can just go for the urban development or smart city development. So as part of some sponsored project, IIT Bombay in Civil Department, we have developed number of flood simulation models. So as part of DST, Department of Science and Technology, after the 2005 flooding in Mumbai, we developed a model, a flood model for a smart city. So the details are available in this journal, Computers and Geoscience in this journal. So for interested, you can look into this paper. So this model is concerned, various components are there, like, so you see that everything is developed in a geography information system, and we used extensively remote sensing data. So if you get the rainfall prediction, and then first we identify the overland, and then overland, there is an overland flow module. And then say from that overland flow, so if, for example, if this is your area, and here you see that this is so-called overland, this is a channel, and then we will be routing, and then at any location we can get to the flooding possibilities. And then also if there is a detention pond, that also we can look into this. And then especially coastal area, if tide is there also, we can do that, and then a flood model is developed, and which gives the inundation. So this shows how we conceptualize, this is the overland flow, this is the channel flow, and then the model is developed, say, by combining a one-dimensional and two-dimensional model, especially with respect to overland flow. So now to make it, especially for smart cities, as I mentioned, if there is a prediction of the rainfall for next 24 hours, 48 hours, so then using this model, we can put it in a WebGIS model. This was developed in a WebGIS platform, and then so we can use it. So at any location we can sit using the computer system. We can see that which area there is a possibility of flooding. So this is all done using say the model which I mentioned earlier, using detail elevation model. And then this is a platform. So here there is if there is say like in Mumbai city, there is a municipal corporation is concerned organization internet available, and then at various locations this model can be used. And this is the development of a WebGIS based simulation model. So here the working methodology includes so here there is a WebGIS client and geospatial database preparation, then detailed elevation model extraction, and as I mentioned already, the flood model is developed, and that will be the simulation, and then this everything is coming into a WebGIS platform, and then we can get for a given rainfall condition there is a possibility of flooding and which area will be flooding and what depth is the flooding, and then accordingly we can have a flood hazard map. So this is this is called Indian Flood Assessment Model tool. So this is the overall system. So there is a WebGIS as I mentioned, and then so there is a platform, and then we can say if a rainfall pattern is known, we can directly predict the flooding possibilities, or even we can generate the flood maps for return periods like 100-year return period, 50-year return period. So everything was developed just like in a Google map. So you can see that if this is your urbanized area, and then this is various say urban areas, especially this is in Navi Mumbai, and then we put all this data, and then if you know the rainfall pattern, then we this is we run the model. So this is the rainfall pattern, and then we can get the hydrograph, and from the hydrograph, say at various locations how the flooding can take place, and then what is the inundated area, all those things we can get through this model. So this model details also you can see in this journal of Natural Hazard Springer, and it was published in 2014. Those who are interested, you can go through it. So this model we used to identify how the flooding is happening in a urban watershed in New Bombay or Navi Mumbai. So this is the area, and here this is called a detailed elevation model, and then land use land cover. This area almost 70% is urbanized area, and here using this this is the rainfall about 775 millimeter rainfall took place in 26 July 2005, and correspondingly how the flooding is taken place. So that is simulated using the model which I mentioned. And now you can see how the flooding is happening. So this is the beginning of the rainfall, and then after 2 hours, so how it is happening, the flooding is continuing. So every hour, minute wise, we can capture the radiation. 2 hours, 4 hours, 8 hours, 10 hours, like that. So you can see here is the creek, and from here the tide is coming in, and then here the rainfall due to rainfall overnight flow. These are all the urbanized areas, and then various pockets flooding and how much depth it is flooding. So that way we can have an efficient tool called Indian Flood Assessment Model, which was developed by IIT Bombay. And now again further development is done in IIT Bombay. So here we developed a flood hazard mapping. Say for example, this is in Mumbai, Mithi River Basin is most of the years flooding is happening and due to the high tide and heavy rainfall. So this is so using the models which we developed, or even we can use commonly available models like HECRAS, HMS models. We can use it, and we developed a flood hazard map. Say for example, this is for 100-year return period, which area is more possibility of flooding, very high, moderate, like that. We can get the flood hazard map, and this shows these details are available in this journal paper. It is published in the Journal of Natural Hazards in 2015. So then using this flood hazard map, we can identify the vulnerability. So we'll be preparing vulnerability maps. So these are various social vulnerability, infrastructure vulnerability, land use vulnerability, social vulnerability. So various vulnerability maps and the flood hazard map can be combined, and then we can generate so-called flood hazard map. So this shows very high risk. This is called a flood risk map. So very high risk areas, some of these areas where especially the Mithi River is flowing, and then high risk areas, moderate risk areas. So like that, we can develop this kinds of flood risk map. So this is very useful, especially if you are going to especially smart city development or any kind of urbanization planning. We can develop these kinds of flood hazard map first, and then vulnerability maps, and then flood risk map. So, and then further, if flood is taking place or there is a possibility of flooding in a particular area, then we can have a Center for Disaster Flood Management, and there, as I mentioned, we can have an organized intranet, and then we can develop a system, an integrated flood management system can be developed, and then we can monitor, and then also we can go for the mitigation measures as shown here. So here, say like disaster impact to assess relief response, recovery, rehabilitation. So this is risk management was after the 2005 flooding in Mumbai. This kind of center was developed in Mumbai city, and then now it is working very efficiently. So before closing this lecture, so as I mentioned, so flooding is a major problem, especially in urban development, especially in smart cities. Flooding is we need to look into in a holistic way. So we need to have a early warning system that is we need to look into. So mechanisms of integrating the scientific and technological and administrative agencies for effective disaster management is very essential. And also we need to look into terrestrial communication links which collapse in the event of that. We need to plan in advance, especially in 2005 flooding, it has happened in Mumbai. And then also we need to look into vulnerability of critical infrastructure, power supply, communication, etc. And these are all the guiding principles as far as smart city development is concerned. So what I was talking, especially an Indian flood model which you developed at IIT Bombay, so which was developed in a geographic information system platform, and the tool can be used to evaluate evaluate the performance of existing network for various scenarios. So we can, as I mentioned, 100-year return, 50-year return like that. We can, whenever we are going to develop an airport or any kind of system, there we can have this kind of flood hazard maps, flood vulnerability maps, and then flood risk map. And then, so this will be also very useful, especially in cities. So if you are going to develop a, say for example, a housing colony or a major infrastructure, then we need to assess what is the possibility of the risk involved or the vulnerability as far as the flooding is concerned. So that way, generation of flood hazard map and identification of vulnerability areas are very important. And these kinds of tools serve as platform for near real-time simulation. And so that is very important in most of the cities, especially when we talk in terms of smart cities. So I am very happy to present this this lecture in the India Constitution Week. And those who have got any questions, you can. I will be very happy to answer. My email is given eldo@civil.iitb.ac.in, and I am thankful to Indian Constitution Week ICW Association for giving an opportunity to present my lecture. And also I'm thankful to my student, Dr. Anand Kulkarni and Dr. Sope for the studies. So if those who have got any questions or any doubts, or if you want any help as far as